So on this one right here, if we want to find out possible solutions to this or possible zeros, we're going to take this -3. See, that's the constant term. And then the coefficient of the leading variable term right there. And we're going to look at the factors of each one of those, okay? Now, -3, it's going to have plus or minus 1 and plus or minus 3. You're always going to throw in both signs, okay? So that gives us 4 terms that are factors of that constant there. And then the leading term is 4, so it's going to have plus or minus 1, plus or minus 2, and plus or minus 4. Because you can have 1 times 4, -1 times 4, and so forth. And then you can have 2 times 2, or -2 times -2. So we've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 possible factors of those two, the leading term and the coefficient of the constant term. Now, what we're going to do to find the possible zeros or solutions is we're going to look at each one of these separately. In other words, we're looking at 1 over 1. Again, throw in the plus or minus. We're going to do the plus or minus 3 over 1 there. And then we'll move on to this. So what we did is we did this one, and then now we're going sort of like how you do with multiplication, you know, when you're multiplying one polynomial times the other, you got to multiply each one and 1 times each one together. So 1 over 2 is the 1/2, but again, we throw in the plus or minus. We do 1 over 4, again, the plus or minus. And then we're going on to the next one, 3 over 2 plus or minus, and then 3 over 4 plus or minus. So we got 1, 2, 3, 4, 5, 6, doubled because of the negative ones. So that's 12 possible zeros. Okay. So we want to find all zeros of this one right here, for example. They're not going to go, this one was just to show you how to find them. They're giving you one that's a little bit easier to do here first, because this can be a little bit drawn out process for one that's got something like an x to the 5th. The one I'm going to show you a bit later is like an x to the 4th, but let's start out with this. All right, so we got the -2, all right, and then we got just a 1. Okay, so the factors of 2 are 1, -1, 2, -2. And then the factors of 1 over here, remember the coefficient of that x term there, x cubed is just 1. So we got plus or minus 1 there. So there's really only 4 of them there now. So now we're just going to use the synthetic division to do 1, -1, 2, -2, if need be. We may not need to do all of them. All right, so they start out with -2, okay? So you remember the way that the synthetic division works? You put the coefficients 1, 1, -5, 2, 1, 1, -5, 2, -2. And then the -2, the first one we're looking at, is going to go in that little block. We bring down that 1 and then start multiplying. -2 times 1 is -2. Add them up. -1. -2 times -1 is 2 positive. Add them up. -3. -2 times -3 is positive 6. Add up -2 and 6 to get positive 4. Now, as I had said, this method is pretty quick to do this. So, because sometimes you're going to have to do it a number of times before you find anything. Now, this right here is not 0, so this is not a solution. But if you remember from last class, we did learn that if we were to stick -2 into this function, that would be the functional value. But we don't need it. I'm just pointing that out, just to remind you. Now let's just do the -1. So again, 1, 1, -5, -2. Bring down 1. -1 times 1 is -1. Add them up at 0. -1 times 0 is 0. -5, -5. -1 times -5 is 5. Again, you're going to come with 3. So this is not a solution, not a 0. So they're doing this specifically in an order just to show you that it is possible you might not get it until the very last one. But in any event, now they're doing 1 and 2. They're doing the positive ones. So bring down the 1. 1 times 1 is 1. Add them up, it's 2. 1 times 2 is 2. Add them up, -3. 1 times -3 is -3. Add them up, -5. Not a solution. But on the last one, which is the worst case scenario, 1 over 1, and 1 comes down and then multiply. 2 times, I'm sorry, 2 plus 1 is 3. 2 times 3 is 6. Add up to 1. 2 times 1 is 2. -2 and 2 is 0. So we found that this thing has a solution. In other words, the original one has a solution at x equal to x is equal to 2. All right, now we can also use this right here, the 1, the 3, and the 1, because that is going to be another function that we can then use. See here, the 1, the 3, the 1, and the 0, because there was no remainder. That means we can write this as, now you remember, if x is equal to 2, that means you're subtracting 2. So it's going to be x minus 2 times, and then open up your parentheses, and you're just going to put these coefficients here, because remember, this is now represents an x squared, 1x squared. And then this one represents the 3x. And then this one represents 1. Now, this right here should be easier to solve. We could use the synthetic division again here on this one. But, well, look at what we can do. We can just throw it into the quadratic formula. And you know why? What would have happened? Essentially, though, if we had used the synthetic division, we're going to run into, because you can see this, it's got an irrational solution. These would have been hard to find with the division. All right. So now, putting this in, remember, A is 1, B is 3, C is 1. Put it in the quadratic formula. That's usually the best one to do it with, because it may not be factorable, and this one was not factorable. So the quadratic formula is your friend. If you cut on the complete and square, we did a little bit about that at the beginning. You can use that, but usually the quadratic formula is the easiest one. -3 plus or minus, square root open up. There's b squared, 3 squared, minus 4 times 1 times 1 all over 2 times 1. And then we've got once you simplify it down, it's -3 plus minus the square root of 5 over 2. So these are irrational solutions. In other words, they're going to have a square root in them that cannot be simplified. You can approximate them if need be, but they're not whole numbers. So that's why they're called irrational solutions, because you can't express them as a fraction, all right? Now, this is fractional, but in other words, there's no normal fraction like, 5/8 or 3/4 or anything like that represents it. It's going to have a square root in it no matter what you do. Okay, any questions so far? All right, so let's see some people showing up here. Let me get them here. I said this doesn't ever affect you or anything, but I do it just because the department wants me to turn attendance in at the end of the semester. So that way, if I'm not there, like in between the semester and students got a question, they'll have the necessary information to talk to them without coming and get me from the top of Mount Everest or something, wherever I'm at during the break. Okay, so there's the three solutions. And if I had mentioned it before, go back to this original one. What this means is the highest power right there, 3, x to the 3, you're going to have at most that many solutions. You could have a repeated solution, like if, you know, remember, well, I can't remember if we talked about it or not because I was looking at the 130 class, but sometimes the parabola or whatever will go and just touch a point and then it'll come back and touch it again at that same point. Well, sometimes you have the same solution when you factor the polynomial that's twice. Okay, like in other words, if you had a perfect square trinomial set equal to 0, um, it would be both the solutions would be the same. So you just gotta realize that at most you may have one. So if you come up with two that are the same, that counts as two. All right, now let's go on to the next thing here. Uh, Now let's just look at one more, and then I'm going to go through a fresh one with you. All right, so they want us to solve this. This is one thing that's kind of important to know. It's kind of, I'll give you a free solution. If you find one, that's what we call I mean, it's a complex one that contains an imaginary um, solution. That's, in other words, that I represents imaginary part of a complex number. You can have a complex number like real numbers. All real numbers are complex numbers, but they may not have that imaginary part. And you can also have just imaginary solutions that have no real part. But what this is basically saying is, and this is why it's important, is just that if you come up with a complex solution that has an imaginary part, then its conjugate is also going to be one of the solutions. In other words, if you come up with a plus bi or a plus I, then a minus I will also be a solution. So you get two for the one kind of thing. So anyway, let's go on this one and then I'll go to the board and do a fresh one by hand. All right, so here's one here. X to the fourth, the highest power. So the 4 we're going to use. And then the 13 is the other number we're going to use. And we're going to put the factors of 13 in the numerator. And the factors of 13 are just 1 and 13, both plus or minus. So there's 4 of them up there. And then the good thing is down here, there's just 1 for that coefficient. It goes down there, so plus or minus 1. So we got 1 over 1, negative 1 over 1. We got 13 over 1 and negative 13 over 1. So now let's just start testing them. Again, this is a pretty simple procedure compared to that long division stuff. In one way, I kind of think that that's why they go over it, is just to show you you should be thankful you got the synthetic division. All right, so -1. So remember, here's the coefficients of the. It was a power. Yeah, cubic. So bring down the one. -1 times 1 is -1. -6, -1 is -7. -1 times -7 is 7. And then 22 and 7 is 29. -1 and 29 is -29. Add that up, -59. And then when you multiply here and get your 59, it's obviously it's not 0. So that's not one of them. But on the next one, we've got 1. Bring that down. 1 times 1 is 1. And we got -5. And then -5 times 1, -5, brings us 17. 1 times 17 and take away 30 is -13. 1 times -13 is -13. And look at that. That was always already a positive 13 up there. So those add out to 0. So x equal to 1 is one of the solutions. All right? There. And then so the other part of what's the rest of the polynomial, factored polynomial, is just this right here. That now is a cube. So 1 cube, -5, x squared, 17x, and then the -3 is a constant. All right, now, what you got to do now is start all over. Now, I would mention, and then the one that we'll see, is it the one that we look at? I can't remember it. Sometimes, just if you remember you factor them by grouping, you can try to do factor by grouping here and solve that. And as a matter of fact, I just remember there was one that that was able to do that I did in the other class. Yeah, there's nothing you can do. Well, yeah, I can't do anything with factoring by grouping on that one. Anyway, so that evidently they think they gave it to us for that reason, just to make us go through this process. So it's actually still the same possible factors, because we could have one repeat, as I said is, but we already know about x is equal to 1. So let's just start doing it again. All right, so they do 1, and what about that? They get a hit right off. So x is equal to 1 is a repeated root. In other words, it's the same as the other one, but it's still going to be in factored form like this. And then we do this one here, x squared minus 4x plus 13. We can just use, again, the quadratic formula on that one. And look at this. All right. At the end of the 9-7, I think it's the last section that we go over is the quadratic formula. And by then you also learned about complex roots. So that's what we're going to get here, because this one wouldn't have been factorable. And it also, it's not rational, but it's complex solution. Because once we put the things in here, the -4 and the 1 and 13, you end up with a negative inside 36, okay? So remember, if you remember, the negative sign comes out as an I, and then you take the square root of 36. So that's how they get the plus or minus 6i. So just notice this, see, that here are two solutions. It's 2 plus 3i and 2 minus 3i. So they occur in pairs like that. And that can be helpful. See, this is what I was telling you, what's called the fundamental theorem of algebra, that the degree of the function, polynomial function, or the highest power, um, then that's how many solutions you can expect. You at most, you may have one that repeats. You see, when they wrote this here, I mean, there was really no sense in writing one both times, but they did. But just to show you, that's 1, 2, 3, and 4. All right, let's see. Let me look at something real quick. All right. So how's it going out there? Y'all still awake?
Yep.
Okay. I'm here barely awake. All right. So we're just going to finish up the roster thing here. All right. So I was going to go look at the book a minute. So it says a mix example 6 and 7. I should have probably been paying attention to beforehand, but I want to look at that textbook and see which one 6 or 7, 6 and 7 are. This class is very similar to Math 130. Um, it's just that this yours has a few more applications in it that are practical, and but they also don't go over some of the more theoretical stuff, which is always good in my head. Okay. Yeah, so this is what they don't want us to mess up, and that's kind of useless in my mind. All right, so let's look on the board here. All right. Let's find a spot to work. All right. I'll come back and put in the powers in a minute because I got to do that by hand. All right, so That's not right. It's a 4. Okay, so there we go. All right, so we're going to go through those same kind of little steps like that. This will be a little bit longer probably than some of them, the ones that we saw. Okay, so P is 15. See, this is P, and then this is Q. So for P, it's plus or minus 1. Plus or minus 1 is going to be a factor in all of them, possible factor in all of them. 3 is also a factor, so we're throwing plus or minus 3. And then plus minus 5 and plus or minus 15. And then Q is just 2, so it's 1 plus or minus and then 2 plus or minus. So then we're going to put together the plus or minus Q. I'm sorry, the P over Q, which is going to be, let's see, well, plus or minus 1. So 1 over 1 is plus or minus 1. 3 over 1 is plus or minus 3. Always throw in both positive and negative. And then 5 over 1 plus or minus 5. All right. Now let's do plus or minus 1 over 2, which is going to be 1/2. All right. And then 3 over 2 is plus or minus 3/2. Hopefully we don't have to do too many of these fractional ones, but sometimes this happens. And then 5 plus or minus. And then 15 plus or minus over 2. All right, so we're going to list all possible zeros using the synthetic division. So let's just go in order. Okay, that's just all the zeros. Okay, we're not going to look for the solutions yet. I'm going to get a little bit better one to do that with. But that's all the possible zeros. This one is, I believe it's like number 4 in the actual textbook. Now for this one, we're going to do the same thing, but we want to also actually find all the solutions. So we're going to. So we want to do list the possible zeros. These are synthetic. And then use the quotient, which is that thing that's left over at the end. All right. So let's start out with the listing. Okay, so remember, P is 2, and Q is also 2. So basically we're just going to have, here we're going to have 1 plus or minus, and plus or minus 2. Okay, and the same thing on this one. All right. So P over Q is going to then process as plus or minus 1, plus or minus 2, and then because here it's 1 over 1, 2 over 1, and then 1 over 2. So it's plus or minus 1/2. All right, so we got 1, 2, 3, 4, 5, 6. So that's not too bad. So let's go ahead and do let's do 1 first. So remember, we're using coefficients here. And remember, you still, if there's one missing, in other words, if there weren't an x squared term, you need to put a 0 there. All right, so bring down the 2. 1 times 2 is 2. 6 and 2 is 8. 1 and 8 is, 1 times 8 is 8. This right here is 13. And then that's going to give us 15. So not this one. Let's see if we can squeeze another one in here. So negative 1 times 2 is negative 2. Add them up. It's 4. Negative 1 times 4. Negative 1 times 1 is negative 1. So that's going to be 1. Again, this is not one of them. All right. Let's see if we can put one more right here. Let's put 2. So bring down the 2. 2 times 2 is 4. Put it right here. Add up 6 and 4 is 10. 2 times 10 is 20. That's going to give us 25. And that's 50, 52. So this one's not it. All right. All right, let's go over to the next slide here. A new board. And we're going to try -2. That's the fourth one. After this one, we got to possibly deal with fractions, but sometimes we can't help that. We need to find at least one. And if we find one, then we can use that to help us with the other ones. To bring down the 2. 2 times -2 is -4. -4 and 6 is 2. -2 times 2 is -4. -2 times 1 is -2. And what do you know it? So x equal -2 is a solution. Now just remember, that means that that's a factor of x plus 2. Okay? Because if we take this and put it over there and put that would be x plus 2, the factor. All right. Now, the other part is this right here. Okay, and then we're going to solve this one right here. In other words, this means a is equal to 2. B is equal to 2. And C is equal to 1. And I'm going to just throw it in the quadratic formula real quick. So -2 -b plus or minus. And it's 2 squared, b squared, minus 4 times 2 times 1. All right, so that's -2 plus or minus, and I'm going to just do all this inside. That's 2 squared is 4 minus 8. So it ends up having a -4 in there. All right, so then this is going to be -2 plus or minus, and then the square root of 4 is 2i. And then all of these are divisible by 2, so we can just divide, take out that common 2 top to bottom. Another way of looking at it is 2 over 4 is 1/2, and so that would also be 1/2. But if you just think about factoring a 2 out in each one, it makes it a little bit easier to think about. So then the solutions are -2 - negative 1 minus I over 2, negative 1 plus I over 2. So there's your three solutions. And remember, it was originally a cubic, so that's what we were expecting to have it, three solutions. Okay. So that's what they wanted to do. This was essentially part C here. All right. Any questions about that process? I think I'm going to go through one more for you. Let's see. So we should have enough time. We just need to find one. All right. Hold on a second. I'll be right back. Let me go over to the textbook here a second. All right. All right, so this was 3.4. All right, let me find the good one here. My glasses. I guess I've got them in my bag. I'll have to get it later. All right, so there's a particular one that I wanted to do, and I can't remember. Where I put it at. I remember working in my 130 class, and it was a neat one. Maybe it was in the previous section. Anyway, I'm getting one. I'm gonna try to deal. Maybe we ought to do one where we have to deal with a fraction. Yeah, let's try. It's not going to change anything. Like I said, it'll just change the math. All right, so let's go back to the board here. Wait a second. Let me split this up so I can see it. I'll be right back. Oh, I'm sorry. I was writing down the wrong darn one. All right. All right, and then I'll write in cube and square. All right. And usually the synthetic division is the first thing we start out because it's easiest. Like I said, it's one of the things you can try, but it may not always work is factoring by grouping. And we may have done one and like that. And then this class, it was in the last section. But anyway, I was just looking for it because it was a neat one. Because you would have thought that you couldn't, that you would have had to go another round on synthetic division. But if you use your factoring by grouping, you could essentially jump to the quadratic and then use the quadratic formula. All right, so P over Q is 1 over 2 plus or minus 1. So that means then the possible solutions are, let's see, was it, hold on a second, was it 1? Yeah, P is plus or minus 1. So it's plus or minus 1. So we got 1 plus or minus, and then we got plus or minus 1.5. All right. Because the P separately, oops, is 1 over 1 over 1.5. So that's what's giving us that. All right, so let's just do them in order. Like I said, it's a fast method, so that's why I'm doing that. I can figure it out another way. But that's really not the scope of the class. Anyway, let's move on. Bring down the 2. 2 times 1 is 2. 3. That's going to be 0. But this one's not. So that's not 1. Something's not right here. Okay. I just want to make sure I have it written down right, because usually the best method is to kind of like take a picture of it and import it on this board, but I got it right. All right, so then we got -1. 2 times -1 is -2. That's going to give us -1. Not this one either. All right, so let's try a fraction one. All right, so all synthetic division always starts the same way. The only time it's going to change is right now because you got a different possible solution. So that's going to be 1. 1/2 times 2 is 1. 1/2 times 2 is 1. 1/2 times -2 is -1. Look at that. So x equal to 1/2 is a solution. Now, just to show you the fractions may not always be that bad. Let's just say if we had done this one first. All right. What would happen? So this is -1. -1/2 times 2 is -1. That's going to be 0. 0 times 1/2 is 3. Negative. So this is going to give us now a positive 3/2. But that's going to be 3/2 and 2/2 is 5/2. So this one wouldn't have been it. But you can see, even with that one, that the synthetic division wasn't too bad. All right. So now this quotient right here gives us 2x squared plus 2x and then this is x. Now, just to show you, in case you kind of forgot, in order when you got x equal to 1/2, to get back to as a factor, you got to multiply both sides by 2. When you multiply those by 2, you're going to have 2x is equal to 1. And then that's 2x minus 1 is one of the factors. Is it written as a factor? All right, so what we got to do is we got to take the second one, the 2x squared plus 2x minus 2, and either factor it or use the quadratic formula. Let's just throw it in the quadratic formula. And I want to do it over here because I ran out of room on that other side. I didn't have any more pages. There's a limit on 20 per board. All right, so A is equal to 2. B is equal to 2. And C is equal to -1. And this is going to be another one that's going to have we could factor it. It's not factorable, but you could factor it if it is, and it might be quicker. And you know what? This is exactly one like very similar to one we had before. Now that first solution was different, but this was one of the same ones. It was -4. So this is going to be -2 plus or minus 2i over 4. Now, what we could have done on this one, if we wanted to, I don't know that would make it any different. You could have taken out a or divided everything by 2 and then just use the coefficient 1, 1, and negative 1. And then you wouldn't have to do this here, but remember, the same thing happened, that it was negative 1 plus or minus I over 2. All right, exact same one as that other one we looked at. All right, so the solutions are 1/2 and negative 1 minus I over 2. And negative 1 plus I. So there's our three solutions. All right. So, any questions? We've got a few minutes left for questions. Oh, I see in your question, Danielle, about the Zoom button. Well, I don't know if I told you before that they were fixing this thing somehow beginning. I think it was the beginning of last week. I remember, or it could have been the week before. I came in to my morning online virtual class, and the Zoom button wasn't there. And I said, "Oh no, it had some kind of an error." And then I said, "Well, I know how to get into it. I can just go through the back way." And evidently, y'all could still see it from Canvas. Is what I understand. And then they told us that that was down, and then that's what we should do it. And it going on for 2 weeks. I don't know, maybe 3 weeks. And they even built a little a link for us to have a front end where you could click on it to get into that back end and get into your classes. And then they fixed it. So, but when they fixed it, the Zoom was taken out of the navigation menus. So I had to go back and put it in, and I didn't think about doing it until right there at the beginning. I mean, right before class. All right. So if you don't have any questions, I'll see you Tuesday. We'll finish up another section Tuesday, and we'll talk about that next test. Like I said, we'll be testing before the end of the month. Okay. All right, so y'all okay? Any last questions? But they did go away. They